So you should have had a go at completing this mind map. The purpose of it is to get you to transform and transfer the knowledge that is in the study pack into more easily learnable chunks. There is this sheet that OCR offer for you to learn different colours of different complexes, but again, there's a lot of information there and it can be a little bit overwhelming. So these mind maps will help you slowly but surely pick up the information. You need to know the basic colours of different aqueous solutions of the hexa-aqua ions. And we can simplify these to these formulas, the copper hexa-aqua ion and so on. What you know is either light or pale blue, pale green, yellow, pale pink, and then it's either pale purple, but if you're struggling and want something to help you really learn it, we could say that that was violet. When we add drops of sodium hydroxide, obviously the OH- ion interacts with the metal ion and we form insoluble precipitates. You need to know the colours of these precipitates, light or pale blue. Don't forget, you must include the word precipitate, not an abbreviation like I've done here. Dark green, orange brown, pale brown. And then in your study pack, just like on this sheet, we've described it as being a dark green precipitate. It's often described, and I think it's more memorable if you describe it somewhat unusually as grey-green. And they've actually used that terminology in exam questions. Now, of all of these, the majority do not do anything when you add excess sodium hydroxide. However, the chromium-3 hydroxide will redissolve. And you end up with a dark green solution of the chromium surrounded by 6 hydroxides. The charge on that will be 3 minus. Each hydroxide has a minus charge, the chromium is 3 plus, so altogether 3 minus. And that is a solution. Now, when we take our hexa-aqua ions and we add drops of ammonia, what's important to remember is that the ammonia solution contains OH- aqueous. It is, if we remember, an alkaline solution because of the OH- ions. So dilute ammonia contains OH-. We already know what's going to happen if we take these ions and add hydroxide. So this column here, this table, is going to be absolutely identical to this table. So it seems a bit bizarre that we're adding ammonia, but what we actually get is hydroxide precipitates. So this knowledge could be tested in two slightly different ways, either with drops of sodium hydroxide or drops of dilute ammonia. Again, the colours of the precipitates are absolutely identical. Now you should be able to fill this in from memory, and that's where you're trying to get to. Now it's important, however, that you don't just keep getting the same copy of this mind map over and over again, because all you will do is learn the order of the colours and not necessarily associate the colours with the ion or the complex. So sometimes you're going to need to mix it up and create your own mind maps, but you must know this information. Now again, going back to your study pack, what we did do was take some of these precipitates and add excess ammonia. We could do that to the copper hydroxide or the chromium hydroxide. The chromium ones are pretty straightforward. Octahedral complex, and all we do is put our 6 ligands, 6 ammonia molecules inside the complex. The ammonias have no charge, so the complex is still 3+. Colour, purple solution, dark purple solution. We could write that as chromium surrounded by 6 ammonias, square brackets to show it's a transition metal complex, and then the 3+ charge. When we do that with copper, again, octahedral complex, sorry, getting ahead of myself there, OH2, OH2, ammonia, 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 4 ammonia, 2 water, all of the ligands neutral, so it's still got a 2+ charge. Dark blue solution. Copper, 4 ammonias, 2 water, 2+. You should be able to give examples. So a question may be, as it was 2 years ago, give an example of a precipitation reaction. And you've got a choice. You could do a precipitation reaction either with sodium hydroxide or with ammonia. The equations are going to be the same. Let's have some state symbols because we've got precipitation. Make sure your S's look like S's. If I did it with ammonia, I would get exactly the same reaction because, of course, as we know, ammonia contains OH-. Here we have some ligand substitution reactions. So if I take my chromium hexa-aqua ion and I react it with excess hydroxide, I imagine I'm going to run out of space there. I'm going to end up with chromium hydroxide 6 times, 3 minus. They're all minus charges. The chromium's 3 plus to give 3 minus, and 6 waters. Obviously, the transition metal complexes are soluble. Chromium. We all love chromium. Chromium hexa-aqua ion plus 6 ammonia. It's just a straightforward swapping substitution. All of the complexes aqueous. A bit more complicated if I do that with copper. Copper hexa-aqua. This time I only use 4 ammonia molecules. I get 4 of the waters swapping for 4 ammonias. Ammonia 3, 4 times. 2 plus and 4 waters come off. So, really good mind map for learning colours, formulae, examples of precipitation reactions. We also have ligand substitution reactions, key colours for key complexes, and their equations. All has to be learned.